Welcome to Ask and Learn.
This problem we have a person carrying some boards on his back, and so I've just kind of drawn a schematic of that here. So here is kind of his legs, and he's bent over, and he's got these boards on his back. So the boards have a weight, and then they act at a distance that we can determine. And he's tilted them at an angle of theta degrees. And so since we don't have any horizontal forces, we know that these guys are both going to be, well, they're going to be equal and opposite. He could actually be, pushing in and out on his legs, but they're going to be equal and opposite, and they're not really going to be a part of our problem. So we have, I'll call F1 our weight. Okay, so that's the minus W in the vertical direction. And its position we can determine is a little bit to the right of the person, and to the right of the origin here. Again, I'm using this as my origin, and then we know that it's 4 times cosine of theta to this point here, and then also some distance in the y direction, but it turns out that that doesn't matter, doesn't come into our problem. P is in the vertical direction and is at the origin. F3 is in the vertical direction and is at 3 units from the, and I'm not sure what units were in here, 3 units from the origin to the right of the origin. So let's see here if we can look that up here. Turns out that the units actually don't matter in this problem. So I'm not even sure if they were given. Yeah, we're in feet and pounds, I guess. So again, as long as we're in consistent, we measure all of our lengths in a consistent unit and all of our forces in consistent units. It turns out in this problem it doesn't matter, and also turns out it doesn't matter what this weight is, because what we're asked is to figure out what the minimum angle is before he winds up tipping over. And so we do force balances in our vertical and horizontal directions, and moment balance, and again I use this as my origin. And we wind up with 3 equations, and we have, we actually wind up with 2 equations because the horizontal force balance is trivially satisfied. So we wind up with 2 equations and 2 unknowns. So we can get V and P in terms of the weight and the angle. And so what we have to do is say, well, we can see here that that P might be negative. So what's happening here is at some point he leans not too far over, and then now he needs to have suction cups on his shoes to keep it down. And since he doesn't, he's going to wind up tipping over. So the center of mass of this whole thing is going to get shift too far to the to one side, and everything tip over. So when we set P to 0, and we see W drops out, and we just get cosine of theta equals 3/4, and that turns out that theta is 41.4 degrees.